This is session number 2. So the first one was significant figures. If you've already seen that one, or if you haven't, it's embedded in this one. So what we're going to do today presumes that you already know that and that you can use that with what we're going to do today. Now, very quickly, we're just going to go over the International Student Units, the SI units, very fast because you have to know them to do what we're going to do. There we go. Okay. Point is, we have to have reference standards in science to measure things. We do have an international system that we use among all scientists. It's called the SI system. The letters are backwards because the name is in French. And there are 5 base units that are used in all of science. You should know them all. One of them is funky because it has a prefix. The rest of them do not have prefixes. The only one that has a prefix is the kilogram. That's abnormal. Most of the time you put a prefix in front of a base unit. In this case, that one has a prefix. Okay? These are the 5 base units you're supposed to know. Several of them you've seen for years. A couple of them you were introduced to in chemistry for the first time, and 2 of them you don't get to until you study physics, which are these 2 last ones. Luminous intensity has to do with the brightness of light. That one's called the candela and is abbreviated CD. And electrical current, which if you've been around a house long enough, you might have heard somebody talk about so many amps of electricity. Amp is short for ampere, which is a person's name. Consequently, that symbol is a capital A. So the ones we're going to use in here most at first, we'll go meters, kilograms, kelvins, and seconds. And then we'll add these others as they pertain to our course. Okay? You also have to know your metric prefixes, and there's just no excuse for not knowing them because all it means is you haven't rehearsed them enough. So if you haven't rehearsed them to the point where you just look at them and know, you got to do that. Okay? We started learning these things in middle school, right? So sometimes you even learn little limericks about King Harry who did so-and-so and died drinking chocolate milk or whatever that was. If you learn that little limerick about kilo, hecta, whatever the strategy was that you learned it, you still got to remember them. I want you not to be so reluctant that you always have to look at a number and write it out in long notation. So 10 to the 6, you should be comfortable to look at and say that's a million. And 10 to the minus 6 is 1/1,000,000th. And it should just come to you that quickly. So the multipliers or the factors here on the end tell us what the prefixes mean. And of course, the way this is built, and British system doesn't work this way, the English-American system doesn't work this way. You can take a prefix, stick it in front of any base unit, and create a new unit that is of a different size. It's a multiple of 10 of the original, right? You can't do this with feet. You don't have centifeet. We don't have those. And that's really one of the reasons why the British system is so cumbersome, is because we divide things into smaller pieces, but we don't stay consistent in how many pieces we divide them. So we take a foot and we divide it up into 12 equal pieces, and that's an inch, but we don't stay consistent, so we don't divide an inch into 12 equal pieces and call that something else. We divide inches into halves or quarters or eighths or sixteenths or 30-seconds, and then we don't go 12 feet and go bigger with that and call that something. We go up 3 feet and call that a yard, and it gets very, very cumbersome because you have to remember the division or the divisor to go smaller or bigger, okay? Yeah, once you've been around it forever, you understand it, but the rest of the world looks at that and says, that's not as easy as doing this, and they decided to go with this. So, to be able to participate on the world scale, we adopt that as well. Okay, so the basic unit of length is the meter. Everybody knows what a meter stick is. We've seen that, there's one right there in front of us. It's just over 3 feet. Other common metric units of length that we'll probably use in this class a lot are centimeters. And we'll do problems about kilometers, although we probably won't be out running them. Sometimes we'll use units of volume, and from our geometry class, basically we figured out that that's a 3-dimensional space. So you have to multiply meters times meters times meters to get that, and you'll get a cubic meter. Cubic meter, though, is a cube with this much on the side, so it's rather big. It's about the size of a washing machine when you get it done. Okay, so for calculating volumes of things that are this big, that's fantastic, but you wouldn't want to go buy this much Coke or milk. Something that would fill a box that size would be beyond what a family or a human being would use, so you need something smaller. The next smaller one down then is divide by 10. You get a decimeter, which is about that long. And if you made a box that long on every side, that's called a cubic decimeter, but we have a different name for it. We call it a liter. Okay, a liter is a cubic decimeter. It's the next size down from the giant box. And that's convenient for, buying a Coke or for family, a 2 liter or whatever. It's a little too much to dose maybe cough syrup. That's just too much. So you want to go smaller than that. You need to take your original and divide it again by 10, and you go down again. You get a centimeter, and you can make a cube out of that, and a cubic centimeter is also called a milliliter. Okay, so we're just getting smaller and smaller and smaller. Okay, and we can do this again and get tiny little amounts, microliters or drops of things. So we can get bigger or smaller using these units, and that's how they work here. Now, being able to convert back and forth in between them means we need to know how many of one is in the other. And sometimes that can get confusing. Okay? I'm going to skip that part because it had more to do with chemistry. Units of mass. We're going to use kilograms for the most part. In this class, you're going to hear me say the letters MKS. I want you to put distances in meters. I want you to put masses in kilograms. And I want you to put time in seconds. Okay? Those are all base units, so we're going to run home to mama, so to speak, and do the base. Common units you're going to use then of mass include kilogram, gram, milligram, and micrograms. All right? Does all that make sense? Now, if you know what a micro is, you know how big a microgram is. It's small. Micro is the Greek word for small, but you need to know how small. So that's a millionth of a gram, and that's really tiny. In this class, weight is different than mass, but we have a whole unit on that, so I'll skip that part. Temperatures, Kelvin. I don't think you need to see any more of that. Again, this is the lesson that we taught in chemistry, so I'm reviewing it to see what you need to know today. Okay. So that was basically the little discussion on units. Now let's get here. We really came to talk mostly about dimensional analysis. And so let's bring that up. Where most of us struggle and run into problems have to do with the math of converting units into one another. And it's an essential skill in science. The word dimensional analysis comes from the units themselves. Units are called dimensions. If you have a 3-dimensional shape, it means you can measure it 3 different directions. So that means you've got meters or centimeters, centimeters, and centimeters. Dimensions are not just centimeters, though. You could have temperature dimensions. Okay? So, often one quantity can be expressed in several different ways. And everybody understands money, so I'm going to do it this way. You got $1, which is the same thing as 4 quarters, which is the same amount of money as 10 dimes, 20 nickels, and 100 pennies. Same buying power, different number. It's very important that we understand that because when we convert units, it's the same size, it's just expressed in a different unit, right? So the same amount of money. And same is true for scientific quantities then. A meter, 10 decimeters, 100 centimeters, 1,000 millimeters. Those all represent the same amount of length. But whenever 2 measurements are equivalent, and that word means, it says exactly what it means, equal value. Okay? So when 2 measurements have the same values, a ratio of those 2 measurements will actually end up to be 1. Why? Because it's the same thing over the same thing. Even though the numbers look different, it's the same thing over the same thing. So, in this case, a meter over a meter should be 1. But 100 centimeters is the same size as 1 meter, so 100 centimeters over 1 meter essentially is also 1. Okay? In fact, you could flip this over like this. It really doesn't matter which one you put on the top or the bottom. As long as you have the same size measurement on the top and the bottom, you've got a factor that equals 1. Well, what if you take another number and you multiply it by your factor? Do you change your number? Well, you change the size of your number, but because you also change your units, you do not change the size of the quantity. That's important. So if I change $5 into quarters, even though I'm going to get a greater number of quarters than dollar bills, I still have the same buying power as $5. That was the essential thing to notice there.
Is Mr. Bossier in here?
No, sir. I haven't seen it. Well, he went back there earlier, but I don't know where he is now.
Okay.
He's getting ready for his classes. Okay. So it comes down to this. If you have 1 meter and you're going to say it's the same thing as 100 centimeters, I want to draw attention to this by things that are large and small in the fraction that I made. the larger unit goes with the smaller number, always. And the larger number goes with the smaller unit, always. Because I will find this on somebody's test on Tuesday where they actually put 60 seconds is supposed to equal 1 minute, and they get their numbers swapped. 60 minutes is a second. They got the numbers in there right, they got the right units in there, but they put the wrong number with the right unit, whatever. Okay? So check to make sure that your smaller number is with the unit that measures something larger, and that the larger number is with what measures something smaller. Okay, well that just says what we said. Now, we're going to take those fractions we just made, and those fractions are called a conversion factor. And by the way, on our diagnostic test, some people didn't recognize what a conversion factor was. When we asked you, what is, can you give us the conversion factor that will turn so many minutes into seconds, they didn't know what to write. Or somebody would just write down 60 seconds. 60 seconds is not a conversion factor. It's a number with a unit on it. What's a conversion factor? It's always a fraction with a certain number on the top and a certain number on the bottom, and units on the top and bottom. Okay, so conversion factors are useful to solve problems where they give you a measurement in one unit and they want it to come out in another one. And when you multiply your measurement by that conversion factor, your number value is usually changed. Does that mean the size of your quantity has changed? No. The actual size of the quantity actually stays the same, but it's being reported in a different number of unit or a different unit. Okay, so the idea of this term, dimensional analysis, then, is to take a question or a problem or a math challenge that's been given to you and break it down by the units, and let the units tell you how to work your way to the end. And so you're going to break a question down, that's the analysis part, by using the units, which are its dimensions. That's the point of what we're trying to do. And we're going to do it in a way like this. How many seconds are in a work day that lasts exactly 8 hours? Let's say you work 8 hours exactly down to the second. How many seconds is that? You might be able to do that in your head numerically, but how would you show that using the technique of dimensional analysis? There's some things you should make note of and write down. The time you worked was 8 hours, and then there are some equivalencies that are going to turn into conversion factors. 1 hour is the same thing as 60 minutes, but that's a different unit. And 1 minute is the same thing as 60 seconds, but that's a different unit. And they want to know how many seconds were worked. So the first conversion factor that we must write has to be written with the unit hours in the denominator. So what we're going to begin with is we're going to take the number we want to convert, 8 hours, and we're going to multiply it by, in this case, 2 conversion factors back to back, but carefully written in place so that the units cancel. And this is what it's going to look like. 8 hours turned into seconds requires turning hours into minutes and minutes into seconds. But these things have to be carefully placed so that the hours cancel and the minutes cancel in a little chain and a sequence of events that goes all the way down across the page. It can be too long, it can be 1 conversion factor long, and if you've been in chemistry and done stoichiometry, it can be 3 or 4 or 5 long, right? So we've seen that before. Okay, so multiplying across here, you would multiply. This is not written here, but this is implied with a 1 underneath it as well, so the numerators would be multiplied to get that number. And the denominators would also have to be multiplied and divided into that, but in this case it's 1 times 1 times 1, pretty much is insignificant for the numerical. Then this number in this case has now been written in scientific notation, and if you need help with that, we'll cover that one in tomorrow's help session, okay? All right. So let's try this. How many minutes are there in exactly 1 week? If you think you know what you're doing, what's the first thing you would start with? To set this up, go ahead.
7 days in 1 week.
Okay, that's an equivalency. So anytime you say 7 days are the same thing as 1 week, this is going to end up in a conversion factor, but it's not one yet. Until you've decided what goes on top and what goes on bottom, you don't have a conversion factor, but you do have 2 things that are equal to each other, which we'll call an equivalency. Okay? So that's 7 days in 1 week. That would be great if they asked us how many days there were, but that's not what they asked.
Well, you have to start with that and then you have to get
Okay, so what else would you need? Let's make a list of things we need. This would help us get from 1 week, we could figure out that has 7 days in it.
24 hours in one.
So you're going to need to know days to something else. So you can get from weeks to days, which now you said one what? 24 hours is the same thing as 1 day. And that would help us get to hours if that's what they were asking, but they didn't ask for hours. Can we get, basically you're putting little stepping stones here. I can get from weeks to days, and I can get from days to hours, and I should be able to get from hours to minutes. So how many hours, how many minutes?
60 minutes, 1 hour.
Okay, 60 minutes, I heard, was the same thing as 1 hour. Okay, I'll just put H for hour. Okay, now I have 3 equivalencies, and I need to be able to do dimensional analysis to put them in the right locations as I go through my dimensional analysis so that I start with what and end with what.
We have to add another one, 60 seconds and 1.
I don't even have enough to get to seconds. Oh, they didn't ask seconds.
Okay.
They said how many minutes. So I'll stop at minutes.
Start with 1 week.
Start with what you wanted to convert, which was 1 week. And now,
7 days.
start conversion factors. Okay, here's what I know. My next conversion factor needs to have week on the bottom so I can get rid of week. Okay? And then I want to know where can I go from weeks. So I look at my options, and the only one that has weeks in it is this one. Looks like I can go from weeks to days. And now I need to bring in the numbers that went with those two things in the right locations. So 1 week goes on the bottom, 7 days on the top. If I stopped and calculated now, I would tell you how many days I worked. But that's not what they wanted, so I want to keep going. Now what? This is going to happen. Weeks are gone. Now I'm in days. From days, I'd like to go somewhere else.
1 day goes on the bottom.
Days are going to go on the bottom, so we get rid of days. Where can we go to from days?
Hours.
2 hours. Okay. Numbers?
24 on top.
24 on the top and 1 day on the bottom. That'll get rid of days. We will now have reported how many hours that is if we calculate now. But we want to go to minutes.
60 minutes on top.
So we just keep doing this. 60 minutes on the top, and the hours will go on the bottom, so we'll get rid of that. And it's 1 hour, you said. Okay, now it's set up right. How are you going to execute the math when you pick up your calculator?
Multiply all the top and all the bottom.
So, as a general rule, we're going to multiply all the tops together to get a top over here, multiply all the bottoms together to get a bottom over here, and divide top by bottom. In this case, we have all ones on the bottom, so that's kind of pointless. So we'll just multiply across the top. I think you can do that, so I don't think I'm going to actually solve for the number of hours, minutes, sorry. The skill that we want is to set up this part. Okay? Got it? All right. Well, that was to convert time, and that was a pretty easy one. How would you do it if you had to do this dimensional analysis by turning, say, kilometers into centimeters? So what if you had 5,552 kilometers, and you wanted to know how many centimeters is that? Can you use the exact same strategy? Okay, then what would you need? You gave me tools, equivalencies last time. What would you need now? You either would have to know how many centimeters or how many kilometers, and that would help you to do this in one fell swoop in one conversion factor. But if you haven't memorized that, then you might want to go back to the base unit. And so why would you do that? Because you memorized what these prefixes meant in relation to the base unit. So that's kilometers. That's 1,000 meters if you memorize what kilo was. So 1 kilometer is the same thing as 1,000. I'm going to use my powers of 10. 1,000 meters. But that's not that. So I'm going to see if I can get from meters to that. Go ahead. Centi? What was the number? I may have heard it, but it's too loud. 100 what is what? 100 meters. 100 meters is a football field.
100 centimeters is 1 meter.
Oh, okay. There we go. We got the right number with the right thing, right? So 100 centimeters is the same thing as 1 meter. Okay, these are the two things we need Now we got to build it. Okay, so let's build it. You're going to write the thing you want to convert. And then you're going to help me from here. Open up a conversion factor. What's got to be on the bottom? So that I can cancel it away. Where can I go to? I come to my tools over here. I can go to meters. Let's get the numbers in. Make sure that the big number goes with the smaller unit and the small number goes with the bigger unit. So, small number goes with the big kilometers, with the big number goes with the smaller meters. Okay, that's going to happen. Am I done? No. I got to meters. I'm going to centimeters. Help me get there. Meters on the bottom. Centimeters on the top. Numbers, we borrow them from here. The small number goes with the bigger unit. The bigger number goes with the smaller unit. Oh, do you know how to do powers of 10? Because I don't need a calculator now. It's just powers of 10. 10 to the third times 10 to the 2. Hold the base and add up the exponents. So that's 10 to the 5 when you do that together, which is just 1 with 5 zeros after it. And if you multiplied 1 with 5 zeros after it by this number, then what would happen to it? You'd get another 5 zeros behind it, right? Okay? If you need help figuring out how to write that in a shortened version, you need to come to the session on scientific notation tomorrow, okay? But right now, if that's a long, written out long, that's 5, 5, 5, 2, and then 5 zeros. 1, 2, 3, 4, 5. Which is really hard to read and count zeros. And we would prefer you write it in a smaller version. Coming back, maybe there's 3, there's 6, that's 8. So 5.552 times 10 to the 8. What? Units are left centimeters. Okay? How does this question change if I ask you nanoseconds or microseconds or giga this? How does it change? The procedure doesn't change, but what do you have to bring with you as tools? You got to know what the values of the prefixes mean, or you can't come up with this, right? And you're stuck. You know how to set it up, but you don't know what the numbers are, right? Okay, so we do this all the time. Now, what if you went from English units to SI units or back again? Can you do that? Yes, you can, but it's not as easy as this. To get from feet to meters, you're going to have to know how many feet are in a meter, and it's just over 3. It's not exactly any multiple of 10. It's a little more complex, and you have to use significant figures in the calculation. Okay? Let's say this way. 1 inch is 2.54 centimeters. So how long is a standard ruler in centimeters? Standard ruler is 12 inches. So 12 inches turned into centimeters is, help me build this. 1 inch on the bottom. Okay. Now I've got sig figs involved. There are exactly 12 inches on a ruler. They're counted. We know that for sure. Right? But in this conversion factor, there are decimals. And whenever there are decimals, we know that this goes to a certain spot and has an estimate. So how many significant figures should I keep after I do this in my calculator? 3. Using the multiplication and division rules. Go with the fewest number of significant figures. So this is a counted number, that's a counted number. That one was actually measured down to 3 sig figs, and it impacts your answer. Okay? So it's a little bit different going back and forth between SI units and British imperial units. Okay? I think these skills are fundamental. They're kind of basic. We're not asking you to do something brand new, but they do need polishing and refreshing. In the back of your book, somewhere around 850 page, whatever, 850 or something like that, there is a section that starts with a purple header up at the top, and it's a review for mathematical techniques, for all the ones we're going to use all year long. And if at any point you reach something and you go, oh, I need to look at that again, explain in a page or two again how that works. They'll show you the technique, and then they'll give you 4 or 5 practice questions just to see if you've got that skill, back up to par. So I recommend that anybody watching this video later actually checks that section out, okay? All right, looks like we're running out of time, okay? So tomorrow we'll pick up with the last section, which is scientific notation, and maybe if we have time, a little precision and accuracy at the end, okay? Thanks.